let's say we have a graph of y equals to x squared as shown below. This graph is from desmos.com, and we wish to find the area. We want to find the area under the curve. We want to find the area under the curve from x equals to 0 to x equals to 4. What do I mean by this? Well, that's x equals to 0. This is x equals to 4. So the area under the curve is going to be this. That is the area under the curve. And we wish to find this. And you may be like, how do we even start? And the answer is, if you want to find exact area, for the exact answer, you have to use fundamental theorem of calculus, and you can use anti-differentiation to figure out the exact answer. But in this video, we are not going to use fundamental theorem of calculus. I haven't even touched what fundamental theorem of calculus is. In this video, we are going to use approximation. We are going to use approximation to estimate what the area under the curve is going to be. And we are going to make approximation using Riemann sum. Riemann sum. And Riemann sum may look hard, but it's really not. All Riemann sum is you're adding up areas of rectangles to approximate the area under the curve. And you may be like, what does that even mean? So let me show you. Let's start with left Riemann sum with four rectangles. And what I mean by left Riemann sum, I'm going to pick the left-hand point of each interval, and I'm going to draw rectangles like this. And why do I know rectangles go like this? Well, to start with, we got four rectangles going on, and since our interval length is 4, each rectangle is going to have a length of 1. And let's say each rectangle has the same width. So in that case, this rectangle is going to have width of 1, this one has 1, this one has 1, this one has 1. So it comes out nicely. And we are going to find areas of each of the rectangles and add them up. And it's going to give us an approximation for the actual area under the curve. So what's the sum of the areas for this? The first one, obviously, that's just a line. And since it's a line, the area is 0. For the second one, the width is 1. How about the height? For the height, we're plugging in x equals to 1 into the equation to find height. So 1 squared is 1, so height is 1. So the area of this is 1 times 1 or 1. For this rectangle, the width is 1 once again, and to find the area, you're going to plug 2 into the equation to find 2 squared or 4. So the area is 4 times 1 or 4. For the last rectangle, the width is 1 once again, and you're going to plug in x equals to 3 into the equation to find the height, which is 3 squared or 9. So the area is 9. So the left Riemann sum is going to be 0 plus 1 plus 4 plus 9 or 14. And as you can see, this is under approximation. This is under approximation of the actual area, because as you can see, the sum of the areas is leaving out some of the parts of the actual area. We're leaving out these purple parts. We gotta add these purple parts to get the actual area. So our approximation of 14 is actually less than the actual one. So it's an under approximation. Now let's use, you have it, you got it. We're using right Riemann sum with 4 rectangles once again. So in this case, instead of picking the left-hand point, we're going to pick the right-hand point. So that's going to be the first one, that's going to be the second one, that's going to be the third one, and this is, if I can draw it, it's not the best rectangle, but this is going to be the fourth one. And what's the sum of the areas of this? Well, for the first one, the width is 1 once again. The height, in this case, you're plugging in 1 into the equation, so the height is 1. So the height is 1 squared or 1, so the area is 1. For the second one, width is 1 once again. For the height, you're plugging in 2 into the equation to get 2 squared or 4, so the area is 4. And for the third one, the width is 1. For the height, you're plugging in 3 into the equation, 3 squared or 9, so the area is 9. For the next one, width is 1, and you're plugging in 4 squared to get the height, which is 16, so the area is 16. And using the right Riemann sum, we get an approximation of not 0, 1 plus 4 plus 9 plus 16 or 30. And later, and is this under approximation or over approximation? It is over approximation because we have the sum, the Riemann sum is actually more than the actual area under the curve. We have this extra part, this extra part, this extra part, and this extra part. So our sum is over approximation. And later we are going to find the actual area under the curve from 0 to 4, and this is how we write it. And I'm going to show you in later videos that this is actually equal to 16. Did I do that right? It is not 16. Ignore what I just said. It is going to be 64 over 3. So the actual area is 64 over 3, or about 21.333. And as you can see, 14 was an under approximation and 30 was an over approximation.